Hello, in today's lesson we're looking at complex numbers. Our essential questions are, what is an imaginary number? What is a complex number? How can you add, subtract, and multiply complex numbers? Imaginary numbers are the square roots of negative numbers. An example of an imaginary number is square root of negative 9, which can be written as square root of 9 times square root of negative 1. We know what the square root of 9 is. That is 3. And the square root of negative 1 is I, because it's an imaginary number. These numbers can all be written in the form of a plus bi, where a plus bi is called a complex number. A and b are non-zero real numbers, and I is an imaginary unit and represents the square root of negative 1. Given that I is equal to the square root of negative 1, then I square is the square root of negative 1 times the square root of negative 1. When I multiply them, I end up with the square root of negative 1 square, and the square root and the square cancel each other out and just leaves me with negative 1. I cubed is the square root of negative 1 times the square root of negative 1 times the square root of negative 1, which gives me negative 1 times the square root of negative 1, and square root of negative 1 is I, so I'm just left with negative I. I to the power of 4 is square root of negative 1 times square root of negative 1 times the square root of negative 1 times the square root of negative 1, which equals 1. The reason for this is because this multiplies to negative 1, and this multiplies to negative 1. Negative 1 times negative 1 is 1. To graph a complex number is using the same idea as if you would graph in the x and y coordinate. Here's the complex plane. Where our x normally is, those are where all of the real numbers go, and where our y normally is, that's where all the imaginary numbers go. So this is our real part over here, and this is our imaginary part. Graphing negative 4, comma, negative 3i. Negative 4 is over here on the left, and negative 3i is at the bottom. So here is graph of negative 4 minus 3i. Find the square root of the number negative 5 times the square root of negative 9. To simplify this, let's break the square root of negative 9 into square root of 9 times the square root of negative 1. We know the square root of 9, that's 3. We also know that the square root of negative 1 is I. Distribute, negative 5 times 3 is negative 15i, and that's our final answer. Add or subtract and write in standard form. To add or subtract complex numbers is the same idea as when you would add or subtract variables. You are combining like terms. Remember, if I don't see a number over here, that's a 1, so I am distributing a negative 1 with 2 and a positive 7i to get 13 minus 2 minus 7i plus 5i. Combine my like terms. I have 13 minus 2, which is 11, and I have negative 7i plus 5i, which gives me negative 2i. And my final answer is 11 minus 2i. Multiply. Write your answer in standard form. To multiply these two quantities, I'm going to use the Punnett square. 9 times negative 4 is negative 36. Negative 4 times negative 2 is positive 8, and I times 1 is I. 9 times 7i is going to give me positive 63i. Positive 7 times negative 2 is negative 14. I times I is I squared. From our first slide, we know that I squared is the same thing as negative 1, so I'm going to replace I squared with negative 1 and simplify this. Negative 14 times negative 1 gives me a positive 14. I'm now going to combine my like terms. I have two like terms over here and two like terms over here. So I've got negative 36 plus 14 and positive 8i plus 63i. And when we talk about standard form, we're using the form of a plus bi. So our constant comes first and then our imaginary numbers. Negative 36 plus 14 is 22. Positive 8i plus 63i is positive 71i. And there is our final answer, which is 22 plus 71i. Find the values of x and y that satisfy the equation 9 plus 4yi is equal to negative 2x plus 3i. Notice we have two variables over here. We have an x and we have a y. To solve for the x, because it doesn't have an imaginary number next to it, I know that it has to be the a part of the complex number or the constant part of the complex number. So what I'm going to do is I'm going to set 9 equal to negative 2x and solve for x by dividing both sides by negative 2, and I get that x is equal to negative 9 halves, which is the same thing as saying negative 4.5. Now to solve for y. To solve for y, I notice that y has the imaginary term with it, which means I'm going to be solving the imaginary portion of the equation. So I'm going to set 4yi is equal to 3i and solve for y by dividing both sides by 4i. I divided by I is 1, and I'm left with 3/4, which is the same thing as 0.75, which means y is equal to 0.75. Check our work by replacing y with 0.75 and replacing x with negative 4.5 and simplifying. 4 times 0.75 gives me 3 times I. Is that equal to negative 2 times 4.5, which is positive 9 plus 3i? Both sides of the equation is equal, and so our work checks out. All right, that's it from me. I'll see you all soon.